Hi there, in this tutorial we're going to take a look at how to create a drags to timer using the BBC microbit. In order to create it we need to have a few parts. The first is a little laser, and with the little laser we also need to have a laser receiver. We need some DuPont wires, these are female to male. We also need some alligator clips, and we need to have a couple of BBC microbits. I've labelled mine start line and finish line. When you have all of these things, you're ready to start creating our drags to timer. We need to create two gates, so let's call them the start gate, and we also need to have a finish gate. When we've got these created, we need to know the distance between them. For the purposes of this example, I'm using a kitchen table, but you might have a much longer, flatter distance that you can use. In my case, the distance between the start gate and the finish gate is 1.35 meters, and it's important to know that to work out the speed of the drags to at the end, as well as the time taken to travel the distance and the terminal velocity. Now I'll connect up the laser first. You can see it has an S and a minus sign. The S goes to positive, the minus sign goes to negative. And you can see that I've connected it up to a little battery pack here, which has got four 1.5 volt batteries, which means that it supplies about 6 volts, which is just a little bit more than what the laser requires, which is about 5 volts. Once connected up, you can see that the laser lights up and it points towards the laser receiver. When I connect up the laser receiver, there are three connectors that I need to be concerned about. The first one I'll deal with is the out. Now the out from the laser receiver, which I'm indicating with yellow, goes to pin 0 on the microbit. The VCC on the laser receiver will go to the 3 volts on the microbit, and the ground on the laser receiver will go to the ground on the microbit. Now this is the same in both the start line and the finish line. In fact, all the wiring is the same at both ends of the runway. When the laser receiver arrives, it has its front surface facing towards the pins and its back surface facing away. Now we need to change that, because what it will mean is that if we wire it up, the wires go directly onto the start gate and finish gate. We don't want that. So the best way around that is to simply bend the receiver sensor over at 180 degrees so that the front of the receiver sensor can be facing directly towards the laser and the wires hang out the back. So I'll connect it all up. As you can see, following the diagram of ground to ground, VCC to 3 volts and out to pin 0. And once I've connected it up, I'll bend the laser receiver sensor over 180 degrees. You can see the microbit is sad at the moment because it's not getting any signal. When I bend the sensor over, you'll see that the microbit gives a big tick. When I press the reset button on the back, so the tick appears, and I can also press button A and it will tell me how much light is coming in. That was 997. If I drive my little car over, you can see the sad face appears again, and when I press button A you can see that the light level is 2. Now I'm going to use that difference between the light level being something like 998 and it being something like 2 when no light is being received, to tell me when the car starts and the car stops, and therefore work out the time and the speed. So we're ready to do a test run now. The ticks are on the start and the end gates, and when I move my car across the start gate, you can see that it gets a different image, and so does the end gate. The smile at the end gate indicates that it's now timing. When the car gets through and goes through the end gate, you'll see that the smiley face turns into a checkered flag, and when that happens, the timing stops. So it looks like our system is all working and we're ready for the final run. If I look at the final data that has been collected, I can see that it took 0.92 seconds for the car to go from the start to the finish line, and if I shake, then I can see that its speed was 3.87 kilometers per hour over the distance. So there are 2 bits of code, one for the start line microbit and one for the stop line microbit. Both of these are available, and the tutorial indicates where you can find them.